Okay, so this is about energy sources and energy transfers. Booklet, we will be discussing about explanations, strategies to how to answer the question. Question number one, a child slides down a slide 7 meters high. The weight of the child is given and the work done against friction is given. So the question is asking what is the change in the GPE and what's the final KE of the child? Look at the working. First of all, we calculate the GPE 250 times 7, 1750. The heat produced due to friction will be the thermal energy wasted during his sliding. It is given 1300. The law of conservation applied. Gain in the kinetic energy when it slides down plus the thermal energy that is lost should be equal to the loss of the GPE. So KE plus 1300 gives 1750 and KE will be 450. So the change in the GPE, all the GPE will be lost and the final KE will be 450. What uses non-renewable energy? It is the solar panel. What process in sun? Nuclear fusion. Okay. The 300 Newton force is applied and how much work is done when the object is moved from X to Y. If it was the work done against friction, then it would have been 300 times 5. If it was the work done against gravity, it would have been 300 times 3, 900. But it just asks work done. So we have to worry about the total work done as force times distance. So it gives 1500. Cyclist travels constant speed. What work done is equal to the heat produced because a constant speed does not give him gain in kinetic energy. Constant speed means air resistance and the driving force are equal, and constant speed means the force of friction in the bicycle is nothing to do with it. It's already as much as it is. So the only choice and the valid choice is that D. 2 kg mass has 300 joules energy. The speed will be this formula, kinetic energy. We input the values and we calculate this value. A rocket of total mass m, traveling at speed v. The engine is fired, fuel is used. The mass of the rocket becomes half. The speed becomes twice. What happens? So we put the original relation for kinetic energy and then we calculate the new one by substituting m as half and v as twice. We put the values and we get 2 times the KE, original KE. So it doubles. A builder lifts 8 slabs from ground to 1.5. So GPE will be this. The power will be energy per unit time. So 200 Newton each slab times 8 divide 48 gives you 50. Question number 9, the input power to a lamp is 6. The lamp wastes this much energy. What is the efficiency? So first of all, we calculate the output power. So the energy it should produce ideally without waste is the 6 watts power times the time 3 seconds 18. Well, it produces 6 times 18 minus 2.7. So the P out is 15.3 divided 3, that is the power out. That was the energy and this is the power. The efficiency will be out over in and 0.85. A person throws a stone, most gravitational energy will be the highest point. The piston of area 10 is pushed away slowly into a very large cylinder containing gas at a pressure. The pressure of the gas remains constant. So in this question, the force of piston is equal to the force of the gas because the pressure of piston is equal to the pressure of the gas. So the pressure of the piston is 10 and the pressure of gas is F divided 10, force per unit area. F here comes out to be 100. So work done by the gas will be F dot D, 100 times 0.1, 10. So C is the choice. Energy released, fusion of hydrogen to helium in the core of the sun. A crane lifts 600 newtons, vertical height 15 meters in 30 seconds, which is the average power. Well, just apply the data in the E is equal to, power is equal to energy energy per unit per time, and this gives 3000. A javelin has a mass of 0.8, is released with this much energy, speed of the javelin. So this is putting the formula, substituting values, comes out to be 17.68. Nearest answer will be 18. Which source releases carbon dioxide? Fossil fuels only. Student uses a Newton meter. Student multiply the Newton meter. So with calculation, it is the work done because Newton meter gives you the force. Multiplying with the distance gives you the work done. 17, 6 bricks. Takes the 6 bricks, climbs up the ladder. Each bricks 25 Newton, climbs up 4 meters in 8 seconds, the power. So just calculate the work done first. 600, power is E divided T, 75. Child of 30 kg is having a speed of this much when reach the bottom. What's his kinetic energy? Very simple question. Kinetic energy, input values, calculate the answer. Constant force F pulls the block W up. So it will be, again, there is no talk about the gravity. So the work done will be force times length, distance. Energy is released in power station. So power station uses fission and sun uses fusion. Just remember these two facts. So this block of 50 Newton is lifted by this height, 1.8 minus 0.6, and that gives the work done, 50 times this, 60. So we have useful output energy and waste energy. The only statement correct is wasted energy and useful output are equal. Look at these arrows, they tell you the story. 23, a swimmer dives deep, high speed, and then he slows down. What's happening? Well, first of all, his GPE is changing into kinetic energy as he's moving down. And while he's moving down, he's also producing some heat because of the drag of the water. Lorry 10,000 and having a 5,000 goes 50 meters high and then comes back. What is the overall gain? So the overall gain will only be for the load because the lorry comes back. So we will consider 5,000 times 10 times 50 gives us this. There are subjects have different masses, different speed. So smallest to largest kinetic energy. Just multiply this substitute these in the formula. That gives you that R is the least and then Q and then P. Formula we will be using here is the kinetic energy formula, half mv square. Earth's surface has geothermal energy. So the detail is given, the diagram is given, read carefully. The question is asking why it must supply more than 54 mg because the external heat that is provided will keep the house warmer than the surroundings. So that's called heating. So it will heat the house because 54 mg is just enough to equate the energy going out. When exposed to light, a solar cell generates electrical energy. Two solar cells of equal area are tested. Each cell is exposed to different sunlight. Well, the efficient cell will be able to produce the same electrical energy from lower brightness. So at X, the sum of Gp and Ke is constant. That's the only statement that works because when he moves up, Gp high, Ke 0 starts moving down, Gp decreases, Ke increases. But at any point, Gpe plus Ke are same, constant. That's the law of conservation of energy applied here. So this one, tricky question. As the ball moves down, while it is changing its GPE to KE, it is also producing some heat. Okay, so GPE will be KE plus heat. And then when it starts moving up, it is again losing the KE, gaining the GPE, but also producing heat. So potential energy plus heat. Transformer question, but related to the power. So the input power is calculated V times I, and that is this. The output power is given as 24. Useful output is 24 watts. Efficiency, input over output. Round it off. Major components coal-fired. The turbine is kinetic energy and generator is electrical energy. These are the forms of the energy in these. Efficiency is output power divided total energy, its input. Actually, this is not this. It will be useful energy output and total energy input, because if it's energy output, it has to be energy input. You can't have power and energy like this in efficiency. What is the non-renewable source? It is the battery in a watch. Why? Because it is well, it is non-renewable. It is the chemical form of energy. It will eventually run out one day. If the watch having small solar panel, it will always be there. Wind turbine can't be used in watch. Hydroelectric power station can't be used in watch. A builder lifts 8 slabs ground to 1.5. Work done will be this. 48 seconds, so the power will be this. Hydroelectric, tidal, fossil. Hydroelectric is renewable, tidal is renewable, fossils no. Mass 5 kg, 4 meter distance carried, constant height. So when the height is constant, there will not be any vertical movement, so there will be zero whirl. Just remember this fact. This is very important. Okay, so coal-fired boiler, turbine, and electrical generator. It is chemical energy and then heat given to boil the water, and that turns the turbine. Kinetic energy, which runs the generator, produces electrical energy. Well, it is nuclear fusion again. The efficiency, so work done calculated this much. Efficiency, the 60,000 is the energy used, so efficiency is 50%. So if the efficiency is given as 65 and input is this, what is the output? Output will be 65% of this, 7.8 kilojoules. Coal is burned into fuel as a fuel to heat water in a boiler, producing steam. Steam drives turbine, which is connected to an electrical generator. So again, chemical, heat, kinetic, electrical. In this, which height is considered to be useful for working the work done? So it is the height B. This is how much the load is lifted. So this is the potential energy. Change in the potential energy will be calculated using the height B. Parachutist opened his parachute falling at constant speed. Well, at constant speed, the potential energy will only be converted to heat because the Ke is constant due to the constant speed. And we have an emergent generator of this much electrical energy in 24 hours produced. The power will be energy divided time gives you this. Okay. The ball is at A, maximum gravitational potential energy. It is where the ball is at the moment. Highest point. This, we haven't done this, but I have just mentioned it here just for extra knowledge. In this question, radium nucleus decays and its mass decreases by this much. How much energy is equivalent to the loss in mass? Remember that in this question, the decrease in mass, well, we have studied that the mass does not change, but in nuclear reactions, the mass decreases and it converts into energy. That is the law of conservation of energy and mass. So that's the Einstein's famous equation. So the mass will be converted into energy using this relationship mc square. Put the values and you get this answer. Again, this is not in your curriculum. Don't worry about it if you don't understand. The energy output of a generator depends on the efficiency, and the efficiency should be output divided input. That should give you this answer. All the other ones are wrong. We calculated this one is correct. Sun has nuclear fusion again. A crane lifts 1000 Newton to 3 meters in 10 seconds. Input power is 300. What is the efficiency? Work done, this. Power out, this. Efficiency, power out, divide power in, 0.6. Here again, output energy and waste energy. So the efficiency will be output energy divided input energy. Waste does not include in the efficiency formula. 600 Newton weighs and he runs up 4 meters high in 3 seconds. What is the power? Work done calculated, divide it with time to get power. A barrel is moved up 0.8. So the work done against gravity will be 2 meters. Sorry, work done against gravity, not friction. So it will be 2000, which is the weight, and times distance it has moved up, 1600. So here the data is given and it is asked for the overall efficiency. So overall efficiency means final energy output divided by original energy input. Ignore the intermediate energy conversions. So that gives 25% as done here. This tricky question, 1 Newton load, adding 1 Newton load gives 1 centimeter extension. If we have the same thing with 2 springs, the load will be divided equally. So 1 Newton load will give 0.5. Another 1 Newton will give, 1 Newton will give 0.5 with the 2 springs, adding 1 Newton. So 0.5. When springs are in parallel, the extension is halved. Remember this step. Well, the graph is showing that the ball is bouncing and losing height. Why? Decreases with time, because the kinetic energy that is gained at the bottom and that should lift the ball back to the original height is losing to heat. Some of the kinetic energy is lost to heat. That's why it shows. Here we have a motor lifting a load. Chemical energy is running the motor and is finally lifting it and giving it potential energy. A choice. Student exercises. The time is this and the power is this. That should give you student exercise in a gym. Which student does the most work? Sorry. So we have 4 different students. Yes, sorry, I didn't read that. 4. So 4 different students. The power and the time should be multiplied to get the energy, which is their work. So this gives the maximum energy. Which formula gives the efficiency? It is the output divided input. Kinetic energy is 400. 2 kg is the mass. Here you get, this is your speed. This question is repeated. Again, this is repeated. Potential energy into kinetic energy because of the overall energy conversion. In a hydroelectric dam, the original energy was height. Due to height potential, final energy is electricity. Fission or fusion. During fission, only statement that is correct from these four is uranium converts into a daughter product and releases energy. All others are wrong. Let's see how they are wrong. During fission, hydrogen converts into helium. No, fission does not do this. During fusion, helium converts into hydrogen. No, it is the hydrogen that is actually converted into helium. And during fusion, uranium, well, uranium does not do this in fusion. 65, you have to calculate the work done using the data, which is this, and then the efficiency will be output work, which is the work done divided input, that is the power given. It gives 0.4, 40%. A ball is dropped. So first of all, it is the kinetic energy. The ball hits the ground, and because it's an elastic object, it gained elastic potential energy. This elastic potential energy works to restore the original shape of the ball, and it is sufficient to bounce the ball back. So the ball gains kinetic energy back. That's why it goes back. And one extra thing here, if the ball is perfectly elastic, it should come back to its original position. That's why when we drop a tennis ball, a cricket tennis ball, it doesn't come back to its original height. But when we drop a toy, the rubber toy ball you get from supermarket, when you drop it, it comes almost back to its original position because it is very near perfectly elastic object. And again, the Einstein's relationship, just read through, just E mc square, input the values. If you have a good command over calculator, you will get this answer. Try this, but it is not in our syllabus. Maximum kinetic energy will be at this point because this is where all the potential energy is lost. Lowest point. Speed of light is this. 2 kg of matter, again E is equal to mc square. So the energy equivalent of the 2 into 2 is the mass, m and c, this, and then squared. So at position 3, first time, it will have most kinetic energy. So it goes there and it comes back, it might lose some energy for facing friction, air. So here, a girl, 500 Newton, runs up in 10 seconds, height is 5 meters. What power is developing? Power is work done per unit time, 250 watts. Here again, mc square applied. Just use this if you want to, but it is not in this syllabus. A car is going along a level road. Petrol is used as input energy, 60 kilojoules. Car wastes this much. What is the efficiency? 45 divided 60. Very simple, 25% efficient. It's a very bad car. Shouldn't buy it. Hydroelectric, tidal, and fossil. Hydroelectric, renewable, tidal, renewable, fossil, no. We have done this before. This one, so the block is moved by 3 meters, 300 Newton. So work done will be 900. Power will be dividing by time, and it will be 45. Which energy change takes place when a bicycle dynamo runs up, turns on? So bicycle is chemical energy of the cyclist turning the bicycle, which produces the kinetic energy, and the tire removes the dynamo, produces electrical energy, and electrical energy of the dynamo converts and turns the light on. The chemical, kinetic, electrical, light. A boy this much weight, runs up this height, in this much time, power will be this because of this relationship. Same question, just look at it. Same thing, just different data. Rock, this much, traveling in space, this speed, kinetic energy, half mv square, 360 joules. Look at this. 6 multiplied 6 squared, 86. Don't forget this. So many students make mistake, lose marks here at this point. Thank you very much.